Greetings, mathy people. This is Mr. Kingsbury coming to you with some more information about cool parts of math. This unit that we're studying is about radical functions. It actually probably should have put radical functions and inverses since inverses was the first part, but whatever. We're going to build into it. So remember, this is Algebra 2. And yes, our unit is radical functions. Today we're going to look at the square root function. And we kind of have a lot to cover today. Don't forget to put your name, your period, and today's date on there, and let's do this. So we actually have two essential questions today. The first one is, what are the important characteristics of a square root function? The second one is, how do I identify how a square root function has been transformed, and how do I write a square root equation given specific transformations? This question may sound a little familiar because we've done transformations for every single family of functions we've looked at. So when I get to that part, you will probably go, oh, Mr. Kingsbury, I know how to do that. It's so easy. That's probably true. And I will try not to inundate you with unnecessary examples, but we got to review it. I'm sure when we get to that part of the test, you guys are going to rock it, though. So without further ado, let's do this. First of all, what are the important characteristics of a square root function? There are several things we're going to look at. The first one would be the minimum or maximum point. This would be either the highest or lowest point. You know what? Let's switch that. Minimum means lowest, so let's go with lowest. The lowest or highest point on the graph. Let's see. So we're going to do minimum and maximum. We will also, of course, do domain, which I'm sure you guys know or remember is all the possible x values. We will do the range, which is all the possible y values. I think we're also going to do some intercepts. So I'll just call it intercepts generally. And when we, there should be a T here. INTERCEPTS, intercepts. And this would be where the graph crosses the x-axis and y-axis. So yeah, let's jump into this. It will probably be helpful if we have a little bit of a reference point. In class, we are going to look at both the square root parent function and the cube root parent function. And in fact, I will do those on the same day, and then we'll just focus more on the square root that day. We'll do the cube root the next day. It'll be awesome. So just in general, let me just give you the square root function. I'm just going to sketch it really quick. And this is by no means exact. But the square root function starts at the origin, and it goes like this. It goes in just the one direction. It stops right here. So it has an endpoint, and it moves in that direction. It could possibly, if we were to flip it, say, it could possibly, if there was a negative in front of it, go like this. That's fine too. And of course, we're going to move it all over the place so that it can be in different places and you can have different intercepts and so forth. In this particular case, the minimum point, the x-intercept, and the y-intercept are all the same. They're all this point. That does not happen often. In fact, this is the only time that this happens. Once you and the maximum or minimum point, they become very separate things. Also, I want to point out this is a minimum because it's the lowest point. This thing is going up and to the right. This would be a maximum because this is going down to the right. So this would be a maximum, and this would be a minimum, like so. So how do I find these things? It depends on what you're given, but let me just give you kind of an example. And believe it or not, the minimum maximum point is the easiest thing to get to. And once you have that minimum maximum point, that will lend itself to the domain and the range. So I'm going to come back to this this picture here in a second, but let me just give you an example. real quick. So let's call it an example. Oh, I'm getting all kinds of excited. Example 1. So we got y equals, oh, you know what? Before I do that, the general form of the equation looks like this. General form. Looks like this. Y equals a times the square root of x minus c plus d. And some of you may be going, Kingsbury, why did you put parentheses around the square root sign? And the answer to that is, I want to make sure that it's very clear whether or not this d goes under the radical sign or not. So I'm going to put the parentheses there to show that that's where it's ending. I also want to make sure that you see that the a is out here and not in the crook of the radical sign there. If the a was in the crook of the sign, that would make it a completely different root than square root. Because it's out in front, we're multiplying the square root by something. So I put the parentheses there just to clarify how I'm communicating. Having said that, now let's give you an example and see what you can do with it. So let's say we have y equals 2 times the square root of x. Oh, that was genius. X minus 5 plus 1. So that's my equation. And we'll look at stuff like this for transformations as well. Right now, though, I just want to deal with my maximum, my minimum, and all that good stuff. I would say that to help us with maximum, minimum, it would be helpful to identify the a value, the c value, and the d value, right? So a is out in front. That's going to be 2. The c value will be underneath. Now see how it's minus c? We have minus 5. So once you take that minus out, we actually just have a c value of 5. And then it looks like the d value, which is on the end, is 1. Now, I wanted to identify that because the maximum or minimum, or if you will, the end point, is going to be, the maximum or minimum is the point c, comma, d. Now that may look familiar to you. When we were dealing with parabolas, quadratic equations and their graphs, this was the vertex. And in fact, anytime you have set this up in what's called vertex form, it's called that because this point that's made up by the c value and the d value is super, super important. And you can find it using this method because the numbers are built into the form. So in this case, the maximum minimum would be 5, 1. The other question, though, is, does it go, is it a maximum or is it a minimum? And there's a couple ways you can do this. If you want to graph it, you can look at the graph. Certainly, if it goes up like this, it's a minimum. And if it goes down like this, it's a maximum. Another thing you might look at, though, is the sign of A. Remember that A has the power to reflect our graph over the x-axis. So a positive A value is going to be this. This gives us a minimum. And the negative A value will make it curve down, which gives us a maximum. Well, our A is positive. And a positive A, we know, gives us a minimum. So not only is the maximum or minimum the 0.5, 1, but it is also a minimum. So there's that. Now, based off of this point, I can write the domain and the range. You may notice that it starts at this point and goes in one direction. That means what you're going to have is a domain and a range that start at this number and either go up or go down. So this will either be the biggest number or the smallest number in the domain and the range, and then we can go from there. So for my domain, I'm going to do less than x less than, and I'll put some numbers in here, and my range will be less than y less than. Because, as we mentioned, this curves up to the right, positive A value curves up to the right. This is a minimum, which we said it's a minimum. Well, if it's a minimum, then the x value of this point is the smallest x value in the domain, and the y value, you know what? I lied. It looks, well, it depends on how it is. You just need to look at it. But because it goes up, the y value is also the smallest. So you can see both x and y are the smallest value here. So 5 will be the smallest x value in the domain. 1, which was the other point, 1 will be the smallest y value in the range. And the side that has the end point, if you will, the maximum or minimum, you make that an or equals 2. Now, depending which way it goes, then you need to decide, does it go into infinity or negative infinity? Please remember, going to the right is positive infinity, and going up is positive infinity. Going down is negative infinity. Going to the left is negative infinity. Well, this is going on the x side is going to the right, so that's infinity. And it's going, this would be going up, so it's going to infinity for the range. So my domain is going to be 5 is less than or equal to x is less than infinity. And my range will be 1 is less than or equal to y is less than infinity. And I feel like I made that more difficult than it needed to be. I promise it's not that big a deal. Excuse me. Then the last thing we have to look at are the intercepts. Where does it cross the y and the x-axis? One of these is much easier to do, right? So we'll have an x-intercept, and we'll have a y-intercept. The y-intercept is going to be easier to do. And the reason for that is, to find the y-intercept, you plug a 0 in for x. Well, if you do that, y equals 2, oh my goodness gracious, times the square root of, this would be 0 minus 5 plus 1. Well, this can be put into the calculator. Pretty straightforward. In fact, let me show you right now on my calculator. So I'll just type it right in. Can you guys see okay? Awesome. All right, so we got 2. I'm just going to type it exactly as I wrote it. Parentheses. Second square root is right here, right? And then underneath that, we go 0 minus 5. And then I will arrow out of that and hit close parentheses. And then I'll go plus 1. And I hit enter. And that's no good. Oh, shoot. It doesn't want to take the square root of a negative number. That's my fault. I'm going to make a slight change to this. We'll make it plus. All right, so make this plus. That's going to make this a negative c. That'll make this a negative 5. It doesn't change anything except that negative goes in front of the 5. That's all. And we'll make that plus. And if I do that, I get 5.47. So 0, 5.47. We'll round to 2 places. That's not bad. That's really not too bad. The other one, though, you're going to have to solve for, because for the x-intercept, we plug 0 in for y. So I would get 0 equals 2 times the square root. I need more space, so I'm going to move this over, okay? I get so tired of my lead breaking. 0 equals 2 times the absolute value of x plus 5 plus 1. So first we'll subtract 1 from both sides. So we get negative 1 equals 2 times the square root of x plus 5. Then we will divide both sides by 2. Remember, this is 2 times this whole thing. I'm undoing times. So I get negative 0.5 equals the square root of x plus 5. To undo a square root, we square both sides. Please make sure when you plug in negative 0.5 squared to the calculator that you use parentheses. If you do this, you will get a negative number, which is not accurate. A negative times a negative is a positive. See, that is the wrong answer. What you want is negative 0.5 in parentheses squared. You should get 0.25. So 0.25 equals x plus 5. We will subtract 5 from both sides. So 0.25 minus 5. And we get negative 4.75. So this will be negative 4.75 comma 0. And that's all of my stuff. And I just realized that this video is starting to go on and on and on and on. We will practice in class a bit more. That takes a little while. So I've done one, and we'll see about doing some more in class and getting some practice there. The other thing I wanted to do is an example or two of transformations, right? So I showed you the equation, y equals a times the square root of x minus c plus d. And in order to identify the transformations, we should probably identify A, C, and D, and then we can interpret them, which we, at this point, should be really, really, really good at because we've done it so much. Remember, A is the vertical stretch or compression. C is whichever way we're moving, left or right. And remember to change the sign first. And then D is up and down. So if I gave you y equals 1/3 times the square root of x minus 4 minus 7, we could identify A, C, and D. A would be 1/3, C would be 4, and D would be -7. Also, I forgot to mention, A is in charge of the reflection over the x-axis. Don't forget that. If A is negative, there's a reflection. I'll do an example for you. So how would we interpret this? Well, this is 1/3. A value. Okay, first of all, the A value tells us if it reflects or not. It's not negative, so there's no reflection. Secondly, the A value tells us if it's a vertical stretch or compression. If your number is between 0 and 1, it's a compression. So this would be a vertical compression by 1/3. C is left or right. A positive C value means we're going to the right. So this would be right 4. And I want to point out, in the actual equation, it looks negative. But when you pull that value out, you change the sign. So it went from being -4 to +4. That's to account for this negative that's already built in. And then the D value is -7. D is up and down. Negative means down, so this would be down 7. Okay. Let me give you another example of that just really quick. Let's say y equals -5 times the square root of x plus 1, and we will do plus 6. So my A value would be -5. My C value underneath here would be -1. It looks positive in the equation. It changes sign when it comes out. And then my D value would be 6. So let's interpret that. A value is negative, so there's a reflection over the x-axis. Also, my A value is between 0, is bigger than 1. And I know some of you are going, but it's negative. That's not bigger than 1. I realize that. Ignore the negative. Interpret the A value. Interpret the negative by itself, and then interpret the number by itself. So I'm looking at 5. 5 is bigger than 1. That makes this a vertical stretch by 5. Whether A is 5 or -5, it's still a vertical stretch by 5. It's just with the negative in front of there, it's also a reflection over the x-axis. Then we've got our C value of -1. C controls left and right. Negative is left, so this would be left 1. And then our D value is +6. D is up and down. Positive means up, so this would be up 6. So there's that. Now the other thing I may do is give you some transformations and ask you to write me an equation. So maybe I'm like, hey, this thing's going to go up 6 and left 9 and be vertically stretched by 3. What's the equation look like? I would say the best thing you can do is identify A, C, and D again. Up 6, up is controlled by D, so that's a D value of 6. It's a +6 because up is positive. Left 9, that's a C value. So C value is going to be 9, and because it's left is negative, that will be -9. That leaves the vertical stretch by 3. That's my A value, so I have an A value of 3. Since there's not also a reflection, that means it is just a +3. So I have my 3 values. Then we go to our equation. Y equals A times the square root of x minus C plus D, and let's plug in. So Y will equal 3 times the square root of x minus negative 9 plus 6. And the only other thing I would do is these two negatives, they need to be a positive. So I would probably rewrite that as 3 times the square root of x plus 9 plus 6. And that would be my equation. Okay, one more and then we'll call it a day. Let's say that I want you to move this thing to the right 6 units. Let's vertically compress it. So let's do a vertical compression by 1/8. Let's move this thing down 7 and let's reflect it over the x-axis. Once again, identifying the A and C and D is going to be hugely important. A, C, D. All right, right 6, left and right is controlled by C, so 6 is going to be a C value. Right is positive, so 6 will be positive. C will be positive 6. Vertical compression by 1/8. Vertical compression is controlled by A, so my A value will be 1/8. And we'll have to decide if it needs to be positive or negative later. Right now, we're going to leave it positive. If we run into a reflection, we can change it to negative. Otherwise, it stays positive. Then we have down 7. Down is controlled, well, up and down are controlled by the D value. So my D value is going to be 7. D is negative. Down is negative. So we're going to make that a negative 7. And lastly, it says reflection over the x-axis. That means you make your A value negative. So I'm going to go y equals A times the square root of x minus C plus D. And let's plug some stuff in. So my A value is negative 1/8. Then we've got x minus 6. And then on the end there, minus 7. It doesn't look like there's anything to simplify. So that's my new equation. And that's how you do that. We will practice more in class. And then I'll give you a little assignment so you can do some of that. And yeah, life will be good. See you later.